Good morning, everyone. Am I audible?
Good morning, ma'am. Yes, you're audible.
And what about the slide? Is it visible?
Yes, ma'am.
Okay, that means we can go ahead with the class today. What was the last experiment that we did?
To determine the alkalinity of supplied water sample.
Yes. So on the last two turns, we had discussed experiments in which you needed to determine the alkalinity of any given sample. And in fact, not only the total alkalinity, but the individual concentration of the ions as well. And today also, we will be discussing an experiment based on water chemistry only. And in today's experiment, your objective will be the determination of total hardness of any given sample, and not only determination of the total hardness of any given sample, but you will also determine the individual calcium and magnesium hardness separately. Now, this objective is different from what you learned in the class. In the general procedure of the experiment that we learned in the theory or lecture class, the objective was to determine the total hardness. That was the similar part. But there you needed to determine the temporary and permanent hardness separately. And for that, what you are supposed to do, if you wish to determine temporary and permanent hardness separately, what you should do experimentally. Come on, speak up. This we have discussed in the class. If you wish to determine temporary and permanent hardness separately, what should be done with the supplied water sample?
By heating it.
Heating. Is that the appropriate term? You need to be more specific. See, if you say heating, that can be any temperature. But what are you supposed to do over here? Still, I can see only 29 attendees in the meeting right now. You people don't join on time. Come on, give me the specific term. Then only I will move forward. Heating to a temperature of 25 degree, 50 degree, 60 degree, will that be sufficient? What is the specific term? What should be done to a water sample if temporary hardness has to be removed from it? If nobody knows the answer, this is so very basic. It has nothing to do with the lecture class. This you have been taught at the basic level when the term hardness was introduced to you. What do? Do you heat it or do you boil it?
Boil it, ma'am.
I'm boiling.
Boiling followed by filtration. This is what should be done, because when you will boil, the temporary hardness causing salts, they will be precipitated. Specifically the calcium and magnesium salts, they will be precipitated in the form of calcium carbonate and magnesium hydroxide. And when you will filter these salts, then temporary hardness will be removed from the water sample. But in today's experiment, we will not be following this path. In fact, because our objective is to determine the calcium and magnesium hardness separately. So we will be following another path or a route, you can say. In fact, what we will be doing, we will be adding sodium hydroxide in excess such that magnesium will be precipitated in the form of magnesium hydroxide. It will be filtered and removed from the water sample, and then you will be only left with calcium hardness in the water sample. So when you will titrate it against EDTA, the hardness that you will get is going to be calcium. And suppose now if you want to find out magnesium hardness, what should be done? If you know the total hardness and the calcium hardness and you wish to find out the magnesium hardness, what operation should you employ?
Ma'am, we can form CaCO3 PPT, then we will separate out calcium, then we can find out magnesium.
You know the total
Like that.
hardness, you know the total hardness and you know the calcium hardness. How can you find out magnesium hardness? That is the question. You don't have to employ any experiment.
Total minus calcium.
Ma'am, we will
Yes,
take the
total
difference.
minus the calcium hardness, and you will get the magnesium hardness. So this is what you will be learning in today's experiment, the experimental procedure for the determination of total hardness and then calcium hardness. And from both these data, you can find out the magnesium hardness. As far as the total hardness is concerned, this has been discussed in detail in the theory class. That is why it has not been mentioned in the theory which I am sharing with you. Is slide number 3 visible to everyone?
Yes, ma'am.
Yes. So we are not discussing that part of the theory which deals with the determination of total hardness, because that has been discussed in the lecture class in detail. We will be only focusing on the determination of calcium hardness individually, whereas as far as the total hardness is concerned, I hope you all remember that for that you need to maintain a pH of 10 by using a buffer. Areochrome black tea will be the indicator. And what is going to be the titrant? What will be filled in the burette? If you wish to determine the hardness of any water sample, what should be filled in the burette? Do you all remember the experiment based on hardness or not? Like it's been, I think, 2 to 3 weeks and you've forgotten everything. Yes, somebody was answering. EDTA solution. Yes, the EDTA solution, the dyed sodium salt of EDTA in the solution form is filled in the burette, and that is why this experiment is a type of complexometric titration. Why complexometric titration? Because a complex will be formed between EDTA and the hardness causing metal ions. Areochrome black tea is the indicator, and the endpoint of the reaction will be monitored by the change in color from wine red to steel blue. Steel blue is going to be the color that will mark the endpoint of the titration. And I hope you all remember that why we need to maintain a pH of 10, why buffer is added in this titration. This I have explained in the class. Now this I will not take up right now. Now, the underlying part that you can see here, this has been changed. If you are sitting with your lab manuals, then you can compare that this portion of the theory has been changed. I think there it is some amine which has been stated for the precipitation of magnesium, but you will not be following that route in the experiment. You will be adding sodium hydroxide in an amount such that the pH of the solution raises to 12.5, and in that process what will happen, only magnesium ions will be precipitated in the form of magnesium hydroxide, and then you can determine the calcium hardness left in the water sample by using Nurexide indicator. So please take a screenshot of this slide, because this portion is not there in the lab manual. As has been stated on the slide, underlying part is different than the matter in PDF available at Institute's website. Is it clear?
Yes, ma'am.
Now let us come to the procedure. The video and the content I will upload in the coming week. Today we will be only discussing the procedure. So see, the whole experimental setup or the procedure is divided into 3 parts. And the first 2 parts, as I have said, that I have taken up in the class already. The first 2 steps will be dealing with the standardization of the EDTA solution. The first step I'm talking about, because the strength of the EDTA solution will not be supplied to you. You will be given an unknown EDTA solution, and you cannot work with the water sample until and unless you know the strength of the EDTA solution. So the very first step is the standardization or the determination of the strength of the EDTA solution. Strength, or you can say normality more specifically. So this is going to be the first step, and in order to carry out the standardization of the EDTA solution, first of all, one needs to prepare a standard solution of water. Standard solution of water, that means the strength of that hard water sample should be known to you. Now, how will that be done? First of all, you will weigh a specific amount of calcium carbonate. That means we are introducing intentionally calcium hardness in the water sample. So you will weigh around 250 mg of calcium carbonate using the analytical balance, and then you will dissolve it in minimum amount of dilute HCl, because calcium carbonate we know is insoluble in water. So if you will straight away add calcium carbonate to water, it will not dissolve. So what is done first? In a dish, what you do, the weighed amount is added to the dish, and then to it you add dilute HCl in small quantities. When you say minimum amount, that means you will check it. You will add dilute HCl until the point you get the effervescence. You will keep on adding dilute HCl drop by drop to that 250 milligram of calcium carbonate. Can you think of the reaction that will be taking place? You can write that reaction in your copies. Calcium carbonate plus HCl. So can you tell me the products that will be formed?
Ma'am, calcium chloride, H2O, and CO2.
Yes, calcium chloride, H2 and CO2 is a very simple reaction. So it is going to be the effervescence, the escape of CO2, which will tell you that the reaction is still taking place. So till the point you get the effervescence, you will add dilute HCl, and that will account for the minimum amount of HCl that needs to be added. As soon as the effervescence stops, you will stop adding dilute HCl to calcium carbonate. Then you will transfer the contents to a 250 ml volumetric flask using a funnel, and with the help of distilled water you will wash the dish, transfer all the content into the volumetric flask, and as I have told you, then you will dissolve the calcium chloride in minimum amount of distilled water. And when calcium chloride is completely dissolved, then you will be adding distilled water in excess such that it reaches the graduated mark in the volumetric flask. And once that is done, you will chopper it and you will invert the volumetric flask such that a homogeneous solution is formed. A homogeneous solution of calcium carbonate, in fact calcium ions I should say, not calcium carbonate. A homogeneous solution of calcium ions will be formed. So for this solution that you have prepared, you know the strength of the calcium ions in the water sample. So is this process clear to everyone? Preparing a known solution of hard water?
Yes.
Yes. Now after this, the procedure will be the same. You will pipette out 25 ml of this standard solution in a conical flask. You will add a specific volume of buffer. 2 ml has been given such that a pH of 10 will be maintained. This buffer solution will be supplied to you, and a measuring cylinder will be placed beside the buffer solution. So you will just take 2 ml of buffer solution in a measuring cylinder and transfer it to the conical flask in which already 25 ml of pipetted standard hard water is present. Again, to the content of the conical flask, you will add few drops of the EBT indicator, and the color that you will see is going to be a wine red color on adding EBT. Why has this red color appeared?
And due to the formation of complex between calcium ion and AVT, like.
Yes, very correct. Yes, that is the right answer, because a complex has been formed between EBT and the calcium ions present in the known water sample. So you will get this wine red color, and you will start the titration. Means the unknown EDTA solution will be filled in the burette, and then when you will start the titration, you will start adding EDTA from the burette into the conical flask, and you will go on doing so until you see a blue color in the conical flask. And this procedure will be repeated for 2 concordant readings and will be noted down in a table, say table 1. And that concordant reading that you will get from table 1, say it is going to be V1 ml. So this whole setup or the steps are being done for the standardization of the EDTA solution. This V1 ml will give you the normality of the EDTA solution when you will apply the law of chemical equivalence. Coming to the second step of the experiment. Now what will you do? Second step deals with the determination of the total hardness of the supplied water sample, the unknown water sample. So this whole experiment, the first 3 steps which I have discussed with you on the last slide, slide number 4, except the first step, the remaining 2 steps, second and third, this will be repeated with the unknown water sample. Means what you will do? Now you will start with 25 ml of unknown water sample, and again you will add 2 ml of buffer, few drops of EBT indicator. Again EGTA will be filled in the burette, and the whole process will be repeated until and unless you get 2 concordant readings for the unknown water sample. And you will record that in another table, say table 2, and the concordant value that you will get from this table, say it is V2 ml. So this step is going to be step number 2. This is going to be the determination of total hardness present in the unknown water sample. Is this clear? Second step.
Yes, ma'am.
And now coming to the final step of the experimental procedure. In this, what will be done? We will be precipitating magnesium in the form of magnesium hydroxide by adding sodium hydroxide in excess. So what is done? First of all, you will start with the pipetting. And this is the same unknown water sample that you have used in second step. So that unknown water sample, you will pipette out 25 ml of it into a conical flask. Then to it you will add half test tube of sodium hydroxide. So the strength is maintained as such of the sodium hydroxide solution that a pH of around 12 is maintained on adding half test tube of sodium hydroxide. What will happen in the procedure? Magnesium will be precipitated in the form of magnesium hydroxide, and in the solution you will only have now calcium ions. To the conical flask, again you will add few drops of the second indicator, that is a urexide indicator. Initially you used EBT, now you are adding urexide. You will shake the flask and titrate it against standard DDTA solution until the color changes from pink to violet. So with this indicator, the color change is different. It changes from pink to violet. And again, you will repeat the titration until you get to concordant readings, and you will record this as observation V3 ml in another table, table 3. As you can see, magnesium hydroxide has not been removed from the conical flask, means that has not been filtered. It will remain as a precipitate at the bottom of the conical flask. So is step number 3 clear to everyone? Yes? Any doubt if you have, you can ask it right now. If no, then we can move forward. Coming to the observations now. So these are the same set of values as you have been doing in the previous experiments. The data may be different. Otherwise, you have to take 3 readings. First is the weight of the empty weighing tube. Then you will weigh approximately 250 milligram of calcium carbonate in the same weighing tube. Then after transference, you will weigh the weighing tube again, and the difference of W2 and W3 will give you the weight of calcium carbonate actually taken. So it was 250 milligram approximately. So it is, as you can see, 248.8 milligram, that much you have weighed. The weight can vary slightly, but whatever is the weight that has been transferred, actually that should be known to you, because your objective is to prepare a standard solution. Standard solution means the strength should be known to you. The strength should be known to you. One more thing in the last slide, again, the underlying part on slide number 5 is different from the content or the matter given in the manual, lab manual. So please take a screenshot of this slide as well, so that you can change the content of the lab manual. Don't copy it as such. Then, have you taken a screenshot of this slide as well, slide number 6?
Yes, ma'am.
Now coming to tables 1, 2, and 3. This is table 1, which deals with the standardization of PDTA solution. The concordant value that you get is approximately around 20.6. And be particular about this. See the volumes, the notation for volumes that I've used in the table, they are V in lowercase initially, and then the concordant value is capital V. So be particular about the notation that is being used. So this is a table that is dealing with the standardization of EDTA solution, table 1, and the concordant value is 20.6. Should I move forward?
Yes, ma'am.
Coming to the remaining two tables, table 2 and table 3. Table 2 is being recorded for the determination of the total hardness of unknown water sample. Again, it is giving you the concordant value as V2ml, and it is around 6.1. And when magnesium hardness will be removed by adding sodium hydroxide in excess, then the hardness left in the water sample will be of calcium, and the concordant value corresponding to it is 4.3 ml, which is V3, capital V3. Should I move forward?
Yes, ma'am.
Yes, ma'am.
So finally coming to the calculation part. Suppose the weight that you have taken in a 250 ml flask, that is W. This W value is the one that you have calculated from W2 minus W3, the first observation slide. So 250 is the volume of the volumetric flask that was used for the preparation of this standard hard water sample. So in W is the weight for 250 ml. How much is going to be the weight per liter? It is going to be 4W, and the normality will correspond to 4W upon 50. Otherwise, what you can do, you can straight away apply the formula of normality, and you will get this as the result. From where has 50 appeared in the formula? Where do you think from 50 has appeared the formula here? Come again, I couldn't hear you.
Equivalent weight.
Yes,
Equivalent weight.
equivalent weight of calcium carbonate. Yes, so if you'll apply the formula of normality, you will get the normality of the calcium carbonate solution. Or in fact, strictly speaking, it should be calcium ion solution. This should be 4W upon 50. So as I have said in the class, you will be applying the law of chemical equivalence thrice. As many as times you will carry out the titration, you will be applying the law of chemical equivalence. Initially, it will be applied between the unknown EDTA solution and the known hard water sample. So from there, you can find out the normality of EDTA. So if the normality of EDTA, suppose is N2, then in terms of W and V1, you will get the value as this, applying the law of chemical equivalence. And then you will apply the law of chemical equivalence between known EDTA solution and unknown water sample. When you will do that, then you will get the total hardness. First of all, you will get the normality of the unknown water sample. You will get the normality of the unknown water sample. that normality will be converted into strength, and from strength you will convert the value into ppm by multiplying by 50,000. Now this I have discussed in the class already. But yes, the law of chemical equivalence has been applied a second time, then only you will get this equation. In the practical files, you will show how you have obtained this formula. You will not write it directly. In your practical files, you will show the step. Means I will see whether you have applied the law of chemical equivalence twice or not. Then again for calcium hardness, it is going to be the law of chemical equivalence between the known EGTA solution and the unknown water sample treated with sodium hydroxide. So if it has been treated with sodium hydroxide, that means magnesium has been removed. So the value that you will get from here, that will correspond to calcium hardness only. Is it clear?
Yes, ma'am.
And finally, you will come to the result. This is how you will report the result. Total hardness, as you have calculated from second step, that you will supply over here. Calcium hardness that you have calculated from step 3 on the previous slide, that you will supply over here. And finally, magnesium hardness will be determined by the difference of total hardness and calcium hardness. So this is how you will report the result of the experiment. In fact, because this experiment has been discussed in the theory class in detail, I think we have covered the instruction really fast. Now, what we can do is, you can do the calculation right now and tell me the results. I will verify the results right now here in the class. The data is all supplied to you. If you want me to go back to any slide, I can do that. Do the calculations quickly and tell me the answers to all these 3 parts, 1, 2 and 3. Do it right now in rough, obviously, because in the practical file you need to do it systematically. Solve it right now and tell me the answer.